So now write down 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube divided by 1 plus 3 plus 5 plus and so on upon n terms is equal n by 24 to n square plus 9n plus 13. So n term is not given. So what are the numerator and denominator? Please observe. First numerator 1 cube plus 2 cube plus 3 cube and so on. That means sum of the cube of cube of natural number. That is equal n square into n plus 1 whole square by 4. So denominator term 1 plus, that means what is the meaning? 1 cube plus 2 cube plus 3 cube plus and so on n cube. Next denominator term 1 plus 5 plus and so on. The nth term is simply sum of n term formula. Or in AP, A is equal to the first term 1, common difference is 2. Sum of nth term formula n by 2, 2a plus n minus 1 into d. N by 2, 2 into a value 1, n minus 1, d value 2. N by 2, 2 plus 2n minus 2, plus 2 minus 2 cancel. N by 2 into 2n, 2 cancel. N into n square. So that is the right value. So nth term, numerator by denominator. Nth term is equal, numerator value is n square into n plus 1 whole square by 4 whole divided by denominator term is n square. So n square is cancelled. Nth term n plus 1 whole square by 4. So you have write the, let s of n be the statement. Let s of n be the statement. Let s of n be the statement. S of n is equal 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus and so on. Plus upon the nth term is n plus 1 whole square by 4 is equal to n by 24 2n square plus 9n plus 13. Right down. So case 1. If n is equal to 1, LHS, n plus 1 whole square by 4, substituting 1. 1 plus 1 whole square by 4. 1 plus 1, 2. 2 square value 4. 4 by 4, 1. RHS. N by 24. 2n square plus 9n plus 13. Substituting n value 1. 1 by 24. 2 into 1 square plus 9 into 1 plus 13. 1 by 24 into 2 1 square, 1 square value 1, 2 1 ja 2, 9 1 ja 9, 2 plus 9, 13, 11 plus 13, 24. The cancellation value is 1. LHS equal to RHS. S of n is true for n equal to 1. Next, case 2. We assume that S of n is true for n equal to k. So simply I will write n replace k. N replace k. S of k is equal 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3, 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 and so on, k plus 1 whole square, k by 24. So 2k square plus 9k plus 13, equation number 1. S of k is true for n, S of n is true for n equal to k. Write down. Next, case 3. To show that S of n is true for n equal to k plus 1. So again write equation 1. S of k is equal 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 and so on plus k plus 1 whole square by 4 is equal k by 24 2k square plus 9k plus 13, equation 1. Write down. Adding on both sides, k plus 1 whole square, k replace k plus 1 whole square by 4. That means adding on both sides, k plus 2 plus 1 plus 2 whole square by 4. K replace k plus 1. So S of k plus 1 is equal 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus and so on k plus 1 whole square by 4 adding k plus 2 whole square by 4 is equal RHS k by 24 2k square plus 9k plus 13 plus k plus 2 whole square by 4. So LCM is 24. LCM is 24 k into 2k square plus 9k plus 13 plus second fraction 1 by 4 into 24. 4 1 ja 4 6 ja 1 6 ja 6 k plus 2 whole square. So divided by 24 LCM 6 2k cube plus 9k square plus 13k plus 6 into a plus b whole square. A square plus b square and 2 square, that is the value 4 plus 2ab. 2 2 ja 4k 2ab. Okay, write down next line. So continue next line. 2k cube plus 9k square plus 13k plus 6k square plus 6 4 ja 24 6 4 ja 24k by 24. Write in order. 2 plus 2 cube 2k cube 9 plus 6 15k square 13k plus 24 37k plus 24 by 24. So next, using synthetic division method and so k cube coefficient is 2, k square coefficient 15, 37, 24, 0. So k value substituting -1. So 0, 2 plus 0, 2. -1 into 2, -2, 13, -13, 24, -24. So k is equal to -1 is transposing left side plus 1. So next, this is 3 terms, ax square plus bx plus c. You have right 2k square plus 13k plus 24. K plus 1 into splitting the middle term 2k square plus 2 into 24 middle term 48. So I will write 16 3 ja 48. 16k plus 3k minus 3k, sorry, minus 3k plus 24. Possible, no? Splitting the middle term is not possible. So you will write k plus 1 into 2k square plus 13k plus 24 by 24. What is the RHS? The RHS term is n by 2, 2n square plus 9n plus 30. Right? This type of term. N replace k plus 1. Please observe. N by 2, that means k plus 1 by 2. k plus 1 by 2. 24, sorry. K plus by 24. N by 24. 2n square. How to write? 2n square. That means 2 into k plus 1 whole square plus 9 into k plus 1 plus 13. I will write 2k square plus 13k write as 4k plus 9k. Also 24 write as so plus 13 వచ్చేదా? So 2 plus 9 plus 13. I will write k plus 1 by 24. 2k square 4k plus 2. 2 is common. K square plus 2k plus 1 plus remaining terms 9k plus 9. 9 is common. Plus 1 plus 13. K plus 1 by 24. 2 into k plus 1 whole square plus 9 into k plus 1 plus 13. So comparing n by 24 to n square plus 9n plus 13. Okay. S of n is true for S of n is true for n equal to k plus 1 by using principle mathematical induction. S of n is true for all n belongs to capital N. Right. Next problem. 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on up to n terms is equal to n into n plus 1 whole square n plus 2 by 12. N terms is not given. You find out nth term. What are the nth term? So 1 square plus 2 square plus 3 square plus and so on. That is sum of square of n terms is equal to n into n plus 1 2n plus 1 by 6. Let S of n be the statement one square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on plus nth term n into n plus 1 2n plus 1 by 6 is equal n into n plus 1 whole square n plus 2 by 12. First case 1. If n is equal to 1, taking LHS, n into n plus 1, 2n plus 1 by 6. Substituting n value 1, 1 into 1 plus 1, 2 into 1 plus 1 by 6. 1 plus 1, 2, 2 plus 1, 3 by 6, 6 by 6, 1. RHS n into n plus 1 whole square, n plus 2 by 12. N value 1, 1 plus 1 whole square, 1 plus 2 by 12. 1 plus 1, 2. 2 square value 4, 1 plus 3 by 12. 12 by 12, that is the value 1. So LHS is equal to RHS. LHS is equal to RHS. Write down next case 2. So last line, S of n is true for n equal to 1. For n equal to 1. Case 2. Case 2. We assume that S of n is true for n is equal to k. So just as n replace k. N replace k. Right on. K into k plus 1 to k plus 1 is equal to k into k plus 1 whole square, k plus 2. S of k is true for next one. S of k is true for S of n is true for n equal to k. Next, case 3. To show that S of n is true for n equal to k plus 1. So once again write this is S of n. Equation 1. S of 1 n equal to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on plus k into k plus 1 to k plus 1 by 6 is equal k into equation 1. K plus 1 whole square, k plus 2 by 12. Adding on both sides. Adding on both sides. First, we have observed LHS. K replace K plus 1. Observe LHS. This is observed. K replace K plus 1. K plus 1 plus 1. 2 into K plus 1 plus 1 by 6. So that is K plus 1. K plus 2. 2K plus 2. 2K plus 2 plus 1 plus 3 by 6. Okay, write down. Next line. S of k plus 1. 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus and so on k into k plus 1 to k plus 1 by 6 plus k plus 1, k plus 2, 2k plus 3 by 6 is equal k into k plus 1 whole square, k plus 2 by 12 plus adding on both sides, k plus 1, k plus 2, 2k plus 3 by 6. Okay, right on. So, what is the common now? So, both side common is k plus 1, k plus 2 common. K plus 1 is common, k plus 2 is common, and denominator by 6 also common. Remaining terms k into k plus 1 plus 2k plus 3 అంతే. So k plus 1, k plus 2, k into k square plus k plus 2k plus 3 by 6. K plus 1, k plus 2, k square plus 3k plus 3. 3k total maybe k plus 2k. Sorry, 2 వస్తుంది. LCM is 12. 1 by 6 into 12. 6 1 ja 6 2 ja 2 రావాలి. By 6 కామన్ ఇస్తున్నాం. ఇక్కడ by 2 వస్తుంది. A plus 1 by 2. 6 2 ja 12. So that's it. LCM is change అవుతుంది. Plus 2 into 2k plus 3. Yes. K square plus k plus 4k 2 3 ja 6 by 6. K plus 1, k plus 2, k square plus 5k plus 6 by 6. So splitting the terms, k square plus 5k plus 6, splitting the middle term. So k square plus 2k plus 3k plus 6. K is common, k plus 2. 3 common, k plus 2. Finally, k plus 2 into k plus 3. So next line. Write down next line. Next line. K plus 1, k plus 2, k plus 2 into k plus 3 by 6. So what is the RHS? K in n into RHS. N plus 1 whole square n plus 2 by 12. 6 into 2 LCM 6 into 2. Please observe. I will missing. 6 2 ja 12. Please observe. 6 2 ja 12. 12, 12. Okay, right down. The next line is k plus 1, k plus 2, k plus 2 into k plus 3 by 12. K plus 1, k plus 2 whole square, k plus 3 by 12. So what is RHS? The RHS is n into n plus 1 whole square, n plus 2 by 12. So n replace k plus 1. Yes, correct. N plus 1. N plus 1 whole square. That means k plus 2. How to write? K plus 1 plus 1 whole square. Because n plus 2. That means k plus 1 plus 2 by 12. Is comparing is correct. So S of n is true for n is equal to k plus 1 by using principle mathematical induction. S of n is true for all n belongs to capital N. Right? Next problem. Next. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on up to n terms is equal n into n plus 1, n plus 2, n plus 3 by 4. First of all, find out nth term. So first, first 1, 2, 3. 1, 2, 3 are in AP. The formula 1a plus n minus 1 into d. That means 1 plus n minus 1. D value also 1. 1 plus n minus 1. That is the value n. Next. 2, 3, 4 are in also AP. Same formula. A plus n minus D value. Common difference is 1. A value 2. Common difference. Each number difference is 1. 2 plus n minus 1. N plus 1. Next 3, 4, 5 are in AP. So A value 3, D value 1. N minus 1 into 1. 3 plus n minus 1. That is the value n plus 2. So n into n plus nth term is equal. Nth term is equal. What are they? N into n plus 1, n plus 2. Write down. Let S of n be the statement. Write down. So S of n equal to 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on. Nth term is n into n plus 1, n plus 2 is equal n into n plus 1, n plus 2 n plus 3 by 4. Case 1. If n equal to 1, LHS n into n plus 1, n plus 2. Substituting value 1 plus 1, 1 plus 2. That is the value 2 into 3, 6 RHS. N into n plus 1, n plus 2, n plus 3 by 6. So 1 into 1 plus 1, 1 plus 2, 1 plus 3 by 6. So 2 into 3 into 4 by 6. That is the value. 2, 3 just 6. 4 divided by 4. Sorry. 2 into 3 into 4 by 4. 4, 4 cancel. 2, 3 just 6. So LHS equal to RHS. S of n is true for n equal to 1. Case 2. We assume that S of n is true for n is equal to k. Substituting. S of k is equal to 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, plus and so on, plus k into k plus 1, k plus 2 is equal k into k plus 1, k plus 2, k plus 3 by 4. S of k is true for n equal to k. Case 3. Write down. Case 3. So case 3. To show that S of n is true for n equal to k plus 1. So write the equation 1 again. S of k is equal 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on plus k into k plus 1 k plus 2 is equal k into k plus 1 k plus 2 k plus 3 by 4. Next, adding on both sides. Adding on both sides. So k replace k plus 1, k replace k plus 1, k plus 1 plus 1 plus 2, k plus 1 plus 2, k plus 3. So S of k plus 1, 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on k into k plus 1 k plus 2 plus k plus 1 k plus 2 k plus 3 is equal k into k plus 1 k plus 2 k plus 3 by 4 plus k plus 1 k plus 2 k plus 3. What is the common in both two terms? K plus 1 is common, k plus 2 is common, k plus 3 is also common. Remaining term k by 4 plus all are common 1, k plus 1, k plus 2, k plus 3 LCM 4, k plus 4 by 4. So I will write k plus 1 plus 2 write as k plus 1 plus 1, k plus 2 write as k plus 1 plus 2, k plus 1 plus 3 by 4. So s of k plus 1 is true for s of n is true for n equal to k plus 1 by principal mathematical induction, by using principal mathematical induction, s of n is true for n or for all n belongs to capital N. Right now. Problem.